with what we have been learning last time, that is your light energy. So in the last two classes we learned about refraction, terms related to refraction, laws of refraction, then we learned about the effects of refraction, then we learned about the refraction in a rectangular glass slab. Today we'll be discussing about refraction of light in a prism. Okay, so if you are not aware of what prism is, so you can see the diagram here. So this is what prism is. So I hope now when you see the picture you get an idea. You all have seen it, isn't it? Now where are the other? So this is your prism. Now when light passes through this prism, it's split into different colors. Okay. As you know, when I am talking about light in general, what am I talking about? I'm talking about the ray of the sun. Now, the ray of the light is generally white in color because we don't see it, isn't it? We don't see so we assume it to be white in color. So when that ray of light, when it passes through a prism, what happens when it emerges out? It emerges out as different colors. It enters as white color, but when it comes out of the prism, it comes out in different colors. Now, why does it happen? This is why, see, this is the refraction in a prism. This is how refraction takes place in a prism. This is the incident ray, or a ray of light comes and hits or strikes on the border or the boundary of the prism. Now when it strikes on the boundary of the prism, it's passing from air to glass. Because you know prisms are made up of glass. So it's passing from air to glass. Which means it's passing from a rarer medium to a denser medium. Now when the ray of light passes from rarer to denser, what happens? It bends towards the normal. So this dotted line is your normal. It bends towards the normal. Now here it's passing through the same medium, that's why it passes in a straight line. Okay, it travels in a straight line. Because there is no other medium here. There's only one medium, that is your glass. So when it passes through this glass, it passes in a straight line. Now, when it's passing from this glass to this air, now when it passes when it comes out from the glass, okay, it's passing from glass to air. Now just the opposite. What is happening? It's passing from denser to rarer. Okay, it's passing from denser to rarer. So it will be moving away from the normal. So see, this is your normal and this is your normal. So you can see the angle here and you can see the angle here, isn't it? So it's passing away from the normal. Okay, it moves away from the normal. So this is how a ray, this is the ray diagram or the process of refraction in a prism. If you are asked to draw the refracted ray or the process of refraction in a prism, this is how you need to draw. Okay, so this one is your incident ray. When this incident ray hits the boundary of the prism and as it enters the glass, it bends towards the normal. Okay, now it passes a straight line through the prism. Now when it emerges out of the prism, it is passing from glass to air, that is from denser to rarer. It moves away from the normal. So this is your angle here. This angle is way much bigger than this angle here. Okay, so this is your incident ray, this is your refracted ray, this is your emergent ray. Now see here, PE stands for incident ray. So this is your incident ray. This PE is your incident ray. EF is your refracted ray. This is your refracted ray. This FS is your emergent ray. Okay, which comes out. That's your emergent ray. This angle formed over here, this angle is called angle of prism. Okay, represented by A. This is your angle of prism. Now angle, this is your angle of incidence. This is your angle of refraction. This is your angle of emergence. And suppose if there was no prism, this light would have traveled in a straight path, isn't it? If there was no prism, prism, this would have traveled in a straight path. Okay, that's why we say this angle has been deviated. So we call this angle to be angle of deviation. So these are the important terms related to refraction through a prism. So you need to understand an incident ray, when it hits the boundary, it moves towards the normal and it passes in a straight path. And when it emerges out, it moves away from the normal. This is how refraction takes place in a prism. Now, we come to another term when we are talking about refraction in a prism. We come to a new term that is called dispersion. What is dispersion? Splitting of light, splitting of white light into different colors. Okay, as I told you in the beginning itself, when white light enters a prism and it emerges out in different colors, isn't it? It emerges out as different colors. It enters as white light, but it emerges as different colors. And this is the reason, this is one phenomenon why we see rainbows after a rainfall and when the sun shines. Okay, so it's actually a phenomenon of dispersion. So what is dispersion? Dispersion is the splitting of white light into 7 different colors. Now why does it split into different colors? It's because white light, it comprises of 7 different colors. Okay, white light comprises of 7 different colors. It's a combination of 7 different colors. So when 7 different colors, they combine together, what is formed? White light. But why do we not see white light when it's traveling on a sunny day? We don't see white light in different colors, isn't it? It's because when it's traveling in air, the speed of all the colors will be the same. Okay, all the colors, all the different colors of the light, all the different colors, the speed will be same in air or vacuum. They remain the same. But as they enter another medium, okay, a denser medium, what happens? Their speed changes. The speed of different colors, they start changing. So some of them travel faster, some of them travel slower comparatively, and then goes on. Okay. So that's why when they enter a different medium, their speed, they start differing from one color to another color. So when the speed differs from one color to another color, what will happen? Different color emerge. Let me give you an example. Okay, say you people are, we see as an audience, what we see a group of students, they are doing a hurdle race. Okay, they are doing some obstacle race. Now, when they are doing some obstacle race, there will be different obstacles on their way, right? So when they start, at the count of 3, when they start, they all start together. But when they all start together, as the hurdles come or the obstacle come, the one who is the fastest will be doing it faster, and the one who is comparatively slower will be behind, isn't it? So same way, when they enter the light, when the white light enters a prism, that means when they enter from air to glass being a denser medium, the speed of the colors, they will be different. Okay, the speed of these colors will be different. The red light will be the fastest, violet the slowest. So, and when they emerge out, red will be fast out, then followed by orange, and then the video, isn't it? And yellow, green, blue, violet. Okay. So the only reason is because the speed of the colors are different in different medium. They are same only in air or vacuum. So this is how actually it happens. See, dispersion of light through a glass prism. Refraction occurs at the air or glass boundary, bending the rays towards the normal and they slow down. So this white light, see, you can see the white light here. This white light is your incident light. Now, since the medium here is air, so it will be a white light. Now, as they enter, what happens? They bend towards the normal because the speed slows down, and then what happens? Then they start speeding up. Okay, they start speeding up because of their speed. So red will be traveling faster, so they'll be going fast, they will move faster, that's why red they just keep speeding. And violet being the slowest, so will be the last. So we see this with your color. Okay, red light bends less because it's refracted less, blue bends best. Well, violet does really, but blue is more memorable. Okay, refraction occurs at the glass air boundary when the rays away from the normal and they speed up again. Red bends the least, violet bends the most. And this band of 7 colors is called spectrum. Okay, when they emerge out as different colors, we call it to be spectrum. Okay, the band of 7 colors are called spectrum. Each color is refracted to a different degree by the glass. That is why the colors disperse into a spectrum of light. So what is dispersion? Dispersion means the splitting of light in a different colors. Spectrum means the band of 7 colors. Okay, the band of 7 colors together we call it to be spectrum. And why do they come out in different colors? Because the speed of the colors in the glass will be different. That means they are different from each other. Now see here, the cause of dispersion. Dispersion occurs because different colors of light travel at slightly different speeds through transparent substances. In glass, perspex, and water, red travels quickest, violet slowest. Okay, so because of the speed of the light, because of the speed, they emerge out as different colors. Which means red travels the fastest in transparent substances and violet is the slowest. That's why we have the color bigger. You can arrange it red, orange, yellow, green, blue, indigo, violet. So this is why dispersion happens. Okay, now when we are talking about dispersion, we come across a term called refractive index. What is refractive index? Okay, refractive index is defined as the ratio of the speed of light in a vacuum to its speed in a specific medium. Now why are we talking about refractive index here? Out of the blue we just discussing about this term, isn't it? Refractive index. Now why it's so important to discuss it over here is because it's the comparison of the speed of light to the speed of light in a different medium. Okay. When we compare the speed of light in air or vacuum to the speed of light in a medium, when we compare them, we come to a term that is called refractive index. Okay, it's a ratio. Refractive index is a ratio between the speed of light in air and the speed of light in a medium. So refractive index is generally represented by the symbol n, small n, not capital N, or a Greek letter called mu. Okay, it's called mu. And the refractive index is defined as, the mathematical expression of refractive index will be n is equals to c divided by v, where c is the speed of light in vacuum and v is the speed of light in a medium. It can be any medium. It can be glass, it can be water, it can be wood, it can be any other medium. Okay, so this is the mathematical expression. So refractive index is represented by the letter n, small n, or a Greek symbol called mu. Okay, the spelling is mu. Now, when we are talking dispersion, how can we just let go the formation of rainbow, isn't it? So this is how rainbow will be formed. After the rainfall, there will be droplets of water suspended in the air, isn't it? Those water droplets, when the sun shines, what happens is the ray of light, when it passes through those droplets, it will speak in a different color. The white light of the sun, they enter the droplet as white light, but when they pass through this raindrop, what will happen? They will speak in a different color because this drop is water which is comparatively denser than the air. So it will be speaking up in different colors. So we see the color, we see rainbow after the rainfall. Okay, so this is how rainbow occurs. In the next class we will be discussing discussing about spherical waves. Okay, so I hope it's clear for you what dispersion is, how refraction takes place in prism, and if there's any doubt, please do feel free to call me. Thank you and have a good day.